Welcome to class 11, chapter 3, trigonometric functions. In our previous modules, we learnt about how to convert degree measure to radian measure and vice versa. In today's module, we shall cover trigonometric functions, sign of trigonometric functions, domain and range of trigonometric functions. Now, consider a unit circle with center at a point here, origin is O, and coordinates of point P are A and B. Let P be any point which rotates along the boundary of circle where AOP, this point is M, AOP, this angle is X and this arc traced by this is X radian. So, since this arc is X, angle is X radian. Why we can call cos X as A? Because cos, you have studied in earlier classes, cos X is defined by adjacent side upon hypotenuse. So, here adjacent side to this X is A because coordinates are AB and this perpendicular is B and hypotenuse is 1 since it is a unit circle. So, adjacent side is A and hypotenuse is 1, therefore, cos X is A and sin X is B because sin X is opposite side upon hypotenuse and opposite side here is opposite to angle which is B and B upon hypotenuse which is 1, therefore, sin X is B. Since OMP is a right angle triangle and in right angle triangle you have already studied in Pythagoras theorem that OM square plus PM square will give us OP square. Now, here OM square is A square and PM square is B square equal to 1. So, you get this result. Now, for every point P on the circle whose coordinates are AB and whose radius, the circle's radius is 1, we can say A square plus B square is equal to 1. Now, A is cos square x and B is sin square x. So, this proves the identity cos square x plus sin square is equal to 1 which you have already studied. Since one complete revolution subtends an angle of 2 pi, if we consider this point as O, 2 pi till this place, it started from this, right? So, it does not make the complete revolution of 2 pi radian does not make any change in the value of this angle x. It is going to remain same only. Thus, for every point on the unit circle, we can say A square plus B square is equal to 1, where A gives us cos square x and B gives us sin square x, which is equal to 1, and this identity you already know. Since one complete revolution subtend an angle of 2 pi radian. So, suppose we are here and if we take one complete round, we reach here and this complete round after reaching this place makes it 2 pi radians. And if we move from AOB, this makes an angle of pi by 2. From AO to AOC, it makes an angle of pi, and from AOC to D if we go, this makes an angle of 3 pi by 2, and if we again reach to this same point from where we started, this makes it 2 pi. So, we can say these angles which are integral multiple of pi by 2, these are quadrantal angles. Now, this is again, this is x, since this is 0 and this is pi by 2. So, after in one quadrant where this angle is pi by 2, we can say cos 0 here at this point is 1. The coordinates of this point A, 1 and 0 are representing the value of cos x and sin x as we have described earlier. The first value gives the value of cos x and the second coordinate, which is y coordinate, gives the value of sin x at every point. So, here at angle 0, the value of cos 0 is 1, the value of sin 0 is 0, and at pi by 2, this coordinate will represent the cos pi by 2 0, sin pi by 2 is 1, and again here at when angle traced by this terminal ray is pi. So, at pi, cos pi is minus 1 and sin pi is 0. When we move at this place after tracing an angle of 3 pi by 2, here cos 3 pi by 2 is 0 and sin 3 pi by 2 is minus 1. We move here further here after tracing the angle of 2 pi. So, cos 2 pi is again this value 1 and sin 2 pi is 0. Now, if we take one complete revolution from the point P, we come back to the same position. Thus, we observe that if x increases or decreases by an integral multiple of 2 pi, the value of sine and cosine function does not change. See, sin 2 n pi plus x, where n pi is integral multiple. Why we called it integral multiple? Because here n is an integer. So, integral multiple of 2 pi plus x will be sin x only. Same way, if we add integral multiple of 2 pi to x, the cos 2 n pi plus x will remain cos x only for any integer n. Now, further sin x is 0. When sin x is 0, the value of second coordinate represents sine, and here also it is sine. So, where else we can find the value of sine is 0? Nowhere else. We have seen at 0 sine is 0, at pi sine is 0. Similarly, if it takes and comes back to the same position, at 2 pi also sine is 0, and when it comes to this position, this makes it 3 pi, at 3 pi also sine is 0. So, we can say sin x is 0 if x is 0, plus minus pi, plus minus 2 pi or plus minus 3 pi and so on. In mathematical language, we can say x is an integral multiple of pi. So, when does cos x is 0? See, first coordinate of this point P represent the value of cos. The cos is 0 at this point and at this point. So, we see at pi by 2 angle cos is 0 or at 3 pi by 2 angle cos is 0. So, cos x is 0 at pi by 2, plus or minus we are taking whether it is taken anti-clockwise or clockwise, that is why we are taking plus minus both. So, at pi by 2, 3 pi by 2 or any multiple of pi by 2, cos will be 0. So, we can say cos x vanishes at when x is odd multiple of pi by 2. So, here we can say sin x is 0 implies when x is integral multiple of pi, or cos vanishes or cos x is 0 implies when x is odd multiple of, here pi by 2 is missing. So, we can write it here. So, cos x is when x is odd multiple of pi by 2. So, all these angles which are integral multiple of pi by 2 are called quadrantal angles. So, here it is 0 degree, here it is pi by 2, here it is pi or 3 pi by 2. So, we will be finding value of sine and cosine function at these quadrantal angles. At 0 degree, the value of first coordinate, that is x coordinate, gives the cos 0. So, cos 0 is 1, and the second coordinate always gives the value of sine function. So, sine 0 is here 0. And similarly, when we reach to this point at pi by 2, these are the coordinates of point B, and the first coordinate, that is x coordinates, gives us the value of cos. So, cos pi by 2 is 0 and sin pi by 2 is 1. When we reach here, after tracing an angle of pi, this coordinates of C point, first coordinates gives the value of cos. So, cos pi is -1 and sin pi is 0. After tracing an angle of 3 pi by 2, when we reach here at point D, the coordinates of D are 0 and -1, where 0 gives the value of cos. So, cos 3 pi by 2 is 0 and sin 3 pi by 2 is -1. Now, after completing the whole revolution, we reach back to same point from where we started. So, 0 degree and 2 pi angle coincides. So, cos 2 pi is 1 here and sin 2 pi is 0 here. So, this makes our quadrantal angles complete. Now, we define other trigonometric functions in terms of sine and cosine functions. As you know, cos x is equal to 1 upon sin x. Now, cos x is in the form of rational number where denominator is sin x and denominator should not be equal to 0. Though sin x should not be equal to 0, for that we need to have x not equal to integral multiple of pi. Similarly, secant x is equal to 1 upon cos x. As you know, here denominator is cos x, again denominator should not be equal to 0. When cos x is not equal to be 0, we need to have x not equal to odd multiple of pi by 2. Similarly, we can find out here tangent x is sin x upon cos x, where cos x is in the denominator. Same thing applies, cos should not be equal to 0. Therefore, x should not be odd multiple of pi by 2. In case of cot x, denominator is sin x should not be equal to 0. Therefore, x should not be n pi, integral multiple of pi. Now, we have shown for all real x, sin square x plus cos square x is equal to 1 in our previous slide. From this, we can easily find out these formulas. How? By dividing this, if we divide this relation by sin square x both side, then sin square x upon sin square x will give us 1. And cos square x upon sin square x will give us cot square x, and 1 upon sin square x will give us cos x square x. This way we will find this relation. But if you will divide this relation or sin square x plus cos square x equal to 1 by, instead of sin square x, if we divide it by cos square x, we will get this relation. See how? Sin square x upon cos square x, tangent square x, cos square x upon cos square x 1 and 1 upon cos square x secant square x. So, these relations or identities we will be using further in the questions. So, students, in your earlier classes, you have already studied the values of trigonometric ratios for angles 0 degree, 30 degree, 45 degree, 60 and 90 degree. The values of these trigonometric functions for these angles are same as that of trigonometric ratios. It does not make any difference for functions or ratios. Now, you already know these values for sine, cos and tangent, and in this previous module we studied the value of sine pi, which is 0, and sine 2 pi, again it is 0 because we have just discussed that sine vanishes at integral multiple of pi. And what about sine 3 pi by 2? It is -1. And cos x, cos pi is -1, cos 2 pi is 1, and what about cos 3 pi by 2? It vanishes at odd multiple of pi by 2, therefore, it is 0. And for tangent x, we can easily find the ratio of these two. So, sin pi upon cos pi, this will give us 0, and sin 3 pi by 2 upon cos 3 pi by 2, this is not defined. In short, I am writing ND, and for tangent 2 pi, 0 upon 1 will give us 0 only. Similarly, you can find the values of cosec, secant and cot x because they are reciprocals of this sine, cos and tangent. Let us do one. For we will find the values of cosec x as reciprocal of sine x. So, reciprocal of 0 is 1 upon 0, which is not defined. Reciprocal of 1 by 2, which is 2, and reciprocal of 1 upon root 2, which is root 2, and for cos pi by 3 we will write the reciprocal of this, which is 2 upon root 3, and for cosec pi by 2 we will find the value of reciprocal of 1, and for cosec pi reciprocal of 0 again not defined, and for cosec 3 pi by 2 reciprocal of minus 1 will remain minus 1 only, and for cosec 2 pi reciprocal of 0 again not defined. Now, these two for sec x and cot x, this is an exercise for you. You can similarly find out by finding the reciprocal of cos x and tan x. You can fill this table. Now, since AB is any point on the circle with origin O such that AOP angle is x, this angle is x, and if AOQ, if we take it clockwise, this is minus x, right. The coordinates of the point Q will be A and minus B, because here A x axis is positive x axis, therefore, this will remain A only, but since the y axis is here downward, this makes it minus b. This was b vertically and downward it is minus b. Therefore, coordinates of q are a comma minus b. Now, see, if we want to find out the value of cos in the first quadrant, means we want to find out cos x. For cos x and cos minus x, what is the difference? In first coordinate represent the value of cos, in first quadrant this is cos x. So, cos x is also a, and in fourth quadrant which is cos minus x, which is again a. So, both of these are a. We can say cos minus x is equal to cos x. So, similarly, for sine minus x, if you move in the fourth quadrant means backward clockwise, then it makes it sine minus x is equal to minus sine x. Why? Because in the first quadrant the value of sine was b, in the fourth quadrant the value of sine was minus b. Here when we took sine x it was b, and when we took sine minus x, that is in the fourth quadrant, this was minus b. So, in place of b, if we replace this value, we can write sine minus x is minus sine x. So, since for every point AB on the unit circle, A lies between minus 1 and 1 and also B lies between minus 1 and 1. See how? Now, as you can see from this diagram, the value of A goes maximum up to 1 and minimum up to minus 1. So, value of cos x also is maximum 1 and minimum is minus 1. Similarly, when we see the value at this second quadrant, which is the value of sine. So, maximum value of sine is 1 and minimum value of sine at any angle is minus 1. So, we can say cos x lies between minus 1 and 1 and sin x lies between minus 1 and 1, any real number between minus 1 to 1 for all x. So, with the help of this diagram, we will be discussing signs of trigonometric functions in different quadrants. See, when point is here in the first quadrant, both A and B are positive. Since both A and B are positive, A represents the value of cosine and B represents the value of sine. Therefore, sine and cosine both are positive from 0 to pi by 2. When we come to the second quadrant, means from pi by 2 to pi, here if we move this ray to this point, if suppose point comes to this place and its coordinates will be minus a and b. Here you see first coordinate is minus, that is negative, and first coordinate represents the cos. Therefore, cos is negative and sin is positive in the second quadrant. When we move from pi to 3 pi by 2, which is called third quadrant, and if this point moves to this place, and its coordinates will be minus a and minus b. The coordinates of p will be both negative. Therefore, cos x will be negative as well as sin x will be negative in the third quadrant. And if we move this ray to this place, and suppose the coordinates are here q, as you can see here a is positive and b is negative. A represents cos, therefore cos is positive, and b is negative, which is sin, so sin is negative. So, in short, we can say here sin and cos both are positive in the first quadrant, cos is negative and sin is positive in the second quadrant, and sin and cos both are negative in the third quadrant, and cos is positive but sin is negative in the fourth quadrant. On the basis of sin and cosine, we can find the sign of other trigonometric functions. See how? With the help of this table. Sine and cosine we have already discussed, because tangent is the ratio of sine and cosine. So, we can decide its sign. Similarly, for cos x, which is reciprocal of sin x, therefore, the reciprocals of these sign will remain these same only. And when we reach at sec x, which is reciprocal of cos x. So, cos x, the sign, whatever is the sign of cos x in different quadrants, the sec x will have the same signs, and cot will have the same sign convention as the tangent have. So, students, to remember it and to learn it easily, what we can do is, we can learn it like a sentence after school to college. If you remember this sentence, the first letter of this A represents all, means all the trigonometric ratios are positive in the first quadrant, and S is sine. So, only sine and its reciprocal, which is cos x, is positive in the second quadrant, and in the third quadrant T means tangent, and its reciprocal cot is positive, rest all are negative. And C is cos and its reciprocal secant x is positive in the fourth quadrant, rest all are negative. This will help you to remember the signs of trigonometric functions. Now, sine and cosine are defined for all real numbers. We further observe that each real number x, for each real number x, sin x lies between minus 1 and 1, we have already discussed, and cos lies between minus 1 and 1. Thus, the domain of y is equal to sin x and y is equal to cos x is set of all real numbers. And what about range? Range is the interval, which is closed interval minus 1 to 1, which can also be written like this: y lies between minus 1 to 1. Similarly, for cos x, which is 1 upon sin x, domain where the function is defined and where not defined, we will exclude that. Here we know that sin x should not be equal to 0, and when sin is 0 when x is equal to integral multiple of pi. So, from when finding the domain of cos x, it is all real numbers except the integral multiples of pi. And here we have written like this, where n is any integer. So, range of cos x is a set where y belongs to any real number, but y should be greater than equal to 1 and it should be less than or equal to minus 1. Now, the domain of y is equal to secant x, because secant x is 1 upon cos x. Here cos x, 1 upon cos x should be defined. For it to be defined, it should not be equal to 0, as we have discussed earlier. Therefore, the domain is x belongs to all real numbers except odd multiples of pi by 2 for any integer, any n belonging to integer, and the range is again same as cos x. Here x is y is less than equal to minus 1 and greater than equal to 1. Now we come to domain of tangent x. Tangent x is a ratio of sin x and cos x, where cos x comes in the denominator. Again, cos x should not be equal to 0. Therefore, it is defined for all real numbers except odd multiples of pi by 2, where n is any integer, and range is set of all real numbers. Now, domain of cot x. Cot x is again cos x upon sin x in the denominator. So, sin x should not be equal to 0. Therefore, x should not be integral multiple of pi. So, while defining the domain of cot x, we can write it like a set, all those x except x not equal to n pi. The range is the set of all real numbers. Here the range of, you can notice, range of tangent and cot is all real numbers. So, students, we can easily observe from the previous discussion the behavior of trigonometric functions, and with the help of this diagram, if you remember, where the points A, B, C, if we write their coordinates, coordinates of A are A comma 0, here it is 0, 1, here it is minus 1 and 0, and here it is 0 and minus 1. Now, as you already know that first coordinate represent cos and second coordinate represent sine. Now, see, sine increases from 0 to 1 in the first quadrant. How? Because sine was 0 here and here it is 1. So, it is increasing from 0 to 1, and sine from 1 to 0. In the second quadrant, it is decreasing from 1 to 0. When it comes to third quadrant, from 0 to minus 1, it is further decreasing, and in the fourth quadrant, from minus 1 to 0, it is again increasing. Now, see, for cos function, if we take cos value represented by first coordinate from 1 to 0. In the first quadrant, cos is becoming from 1 to 0, and from 0 to minus 1, it is further decreasing, and from minus 1 to 0 in the third quadrant, it is increasing, and from 0 to 1, it is again increasing. So, in the first and second quadrant, it is continuously decreasing. In the third and fourth quadrant, the value of cos is increasing. Now, tangent x. The value of tangent x depends upon ratio of sine and cos. Now, tangent moves along with value of sine. It increases from 0 to infinity, and here in the second quadrant, it increases from minus infinity to 0, and in third quadrant, it increases from 0 to infinity. In the fourth quadrant, it increases from minus infinity to 0, and similarly, you can find this behavior for cot, secant and cosec from this table. So, this was end of module 3. In our next module, we shall cover graphs of trigonometric functions and examples. Thank you.